This is the second and final video on substitution. So we'll work through two examples. We're going to do part C and we're going to do part E. So part D is fairly straightforward, so I want you to look at that in the notes. If you have any questions, send me an email. But I'm going to do 4 out of the 5 examples here. And so here we have another definite integral from 0 to 1/2 of x divided by 1 minus x squared under the radical. The derivative of 1 minus x squared is negative 2x. Negative 2x is an integer multiple of x, so this is a good indication that we want to use substitution. So we'll set u equal to 1 minus x squared. Du then is negative 2x dx. And here, to make things a little bit easier, we're going to solve for dx in terms of du. So we divide both sides by negative 1/2, and we have dx equal to negative 1/2 du. Now let me say, when we're using substitution, multiplying or dividing by a constant is the only thing we're allowed to do to du. So you're not allowed to add things to du, you're not allowed to substitute du into functions. The only thing that's legitimate, the only thing you're allowed to do with the du is multiply or divide by a constant. So here we just divided both sides by negative 2. And now we do our substitution. So this integral, we're now going to substitute in terms of u. So 1 divided by 1 minus x squared under the square root is 1 divided by square root of u. The dx is negative 1/2 du. So we have our negative 1/2 multiplied by du. And then we change our limits of integration. When x is equal to 0, u is equal to 1. And when x is equal to 1/2, u is 1 minus 1/2 squared, or 1 minus 1/4, which is 3/4. Remember, a definite integral is a number. So we've taken this number and we've rewritten it a different way, so we don't have to substitute back from x to u. So we take this, we find our antiderivative. 1 divided by square root of u is the same as u to the negative 1/2 power. So we just reverse the power rule here to get our antiderivative. Substitute 3/4, substitute 1, and we subtract. So we have negative square root of 3 over 2 minus our negative 1. Negative 1 is what we get when we substitute 1 in to negative u to the 1/2. This is a subtraction sign. That is part of the definition of this. And so we can simplify this. This is 1 minus square root of 3 divided by 2. 1 minus square root of 3 divided by 2 can be written this way. I'm not picky about that. You can leave your answer like this, or 1 minus square root of 3 over 2, which is in the notes, or like this. Part E is a different kind of substitution. So here we have an x, we have a square root of x plus 1. This one's a little bit hard. The thing that's making this hard is this radical. And so we're going to set u equal to x plus 1. If u is equal to x plus 1, then du is equal to dx. Du is allowed to be dx. When you're doing a substitution, do not set u equal to x. If you set u equal to x, what will happen is you'll simply rewrite this in terms of u instead of x, and you'll have the exact same problem just rewritten. Now, in Calculus 2, you're going to learn a technique of integration called integration by parts. When you're using integration by parts, then yes, sometimes you do let u equal x. But with substitution, you never do. But what you can have is du equal to dx. Now, when we set u equal to x plus 1, we solve for x. X is equal to u minus 1. These two things are very helpful. X becomes u minus 1. Square root of x plus 1 is square root of u. And now we can distribute through, because multiplication distributes over addition. And I rewrote these in terms of exponents to make finding antiderivatives easier. So we have u to the 3/2 minus u to the 1/2. We find an antiderivative, 2/5 u to the 5/2 minus 2/3 u to the 3/2 plus our arbitrary constant. This is an indefinite integral, so our answer needs to be a function or a class of functions. We cannot give an answer in terms of u. We have to give an answer in terms of x, so we substitute back. U is equal to what? U is x plus 1. So we substitute x plus 1 for u right here, and we substitute x plus 1 for u right here. And this is our final answer.